talk to you today about some acid, man. Acid-base balances, man. Acid-base balances. Okay? So first, what I want to know is I want to know how much you know about acid. Well, I'm going to tell you some stuff about acid and bases and trying to balance the two in the body. Our body doesn't like acid and base to be imbalanced. Bad things happen, man, with the acid. Bad things happen. If all this stuff's out of whack, our body doesn't like it. Doesn't like it. Now, there's really 3 chemicals here that we're going to be learning about, and 2 body systems that we're going to be studying today. Man, let me tell you, the lungs and the kidneys got it going on when it comes to acid balance, acid and base balance in our body, okay? First, I want to tell you, I got some CO2. It's a chemical. It is happening with the lungs. This is the only chemical that the lungs have to try to balance out some acid and base imbalances, okay? Then the kidneys come along, and they got 2 toys to play with. That's right, bicarb and hydrogen. One is a base, and one is acid, okay? So that's good. That's good. We got some balancing stuff going on, right? Now, these chemicals right here can either make you very sick, man, yeah, or they can help you compensate for something that's already going on in your body, okay? So let's talk about it. Remember in high school, man? Remember those high school days? Yeah, a little bit. Well, you remember being in the chemistry lab and putting your little dots on the litmus paper, trying to find out the pH of whatever it was you were testing? It's kind of what our blood does. Constantly has to know what's going on with the pH. What's going on with the pH? Our normal pH value is 7.35 to 7.45. Now that's not a big gap, is it? It's not a big gap. We don't have a lot to play. Can't play too much with this. If it's under 7.35, we call that being acidic. We got too much acid, not enough base. If it's over 7.45, we call that alkalosis. That means we don't have enough acid. We got too much base. Okay? So, let's talk about how our body works to maintain and to keep this acid and base balance so we can keep between 7.35 and 7.45. Because I'm going to tell you, the body don't like the acid. If you mess with the acid, you're going to take a trip. You're going to take a trip, but it's going to be to the graveyard. It's going to be a graveyard trip, not a good trip. Okay? So let's start with the kidneys. I just want to tell you that the kidneys, when there's something messed up with our acid-base balance, they are the most efficient workers. They work hard, they work good, and they're good at what they do. The only drawback is that it's going to take the kidneys a few hours to days to get it all worked out. I don't know, but they're good at it, okay? What are the 2 chemicals that the kidneys are working with? Remember? Bicarb and hydrogen, okay? The kidneys are going to either excrete or hold on to what is necessary to keep a balance, okay? They're going to hold or excrete. They're going to do what they need to do. Now the lungs, on the other hand, they work quick, within seconds. Go lungs, but they can't go for a long time. Can't go for a long time, and they're not nearly as efficient as the kidneys. But they do have one chemical that they can try to combat some imbalances with, and that is CO2. Okay? Now you know this. You know that you breathe in oxygen and you breathe out CO2, right? But what happens? What happens if you, I don't know, you barely breathe? What's going to happen to that CO2? Is it going to be able to get out as good as it needs to or wants to maintain a balance? No. It's going to start building up in our little body, isn't it? That's not good. No acid trip here, man. No acid trip. Now, what happens if we're breathing out too fast? we got too much acid coming out, that means there's not enough acid in our body, right? That's not good either. No acid trips this time, man. No acid trips. Okay? So now let's go back let's talk about respiratory acidosis. Okay? So when I say respiratory acidosis, is this a lung problem or a kidney problem? I got this one. It's a lung problem. That's right. It's a lung problem. Respiratory is the key word here. Now, what chemical causes the problem? The only chemical that the lungs have? CO2. Okay? Now, if we're in respiratory acidosis, does that mean we have too much or too little of the CO2? Now, it's acid. Hey, that means we got too much, buddy. We are in acidosis. We are taking an acid trip we don't want to be on. Okay? We got too much. Do you think that to retain the acid, you think that we're hypoventilating, or do you think that we're hyperventilating? That's right. We are hypoventilating. We are barely getting that acid out. Barely getting that acid out. Okay? Now, who's going to come in and save the day with this problem? That's right. Da-da-da-da-da-da. The kidneys going to come in and save the day. That's right. Now, what are they going to use? Bicarb, hydrogen. That's what they're going to use. Okay? The body is going to start excreting the acid and pushing bicarb into the blood to try to balance this acid too much. Right? Now, let me just ask you this. Is the pH going to be high or low with respiratory acidosis? That's right. It's going to be low. It's going to be below 7.35 for respiratory acidosis. Okay? Now, we're retaining CO2, aren't we? That's what's building up in our body. Now, let me ask you. We're hypoventilating. We're not putting out enough CO2, are we? What could be some reasons and some causes for that? Well, I tell you, what if we got a big fat incision? We just had surgery, okay? We are not going to want to breathe good, are we? What if we accidentally maybe took some narcotics accidentally? Or too many sleeping pills? Is our respiratory going to be working good there? No. What if we have a collapsed lung or pneumonia? Okay? We're not going to be putting out as much CO2 as we need to and as we want to, are we? So what's going to happen when we got too much acid? Well, I tell you what, the first thing is, it's going to mess with your head, man. It's going to mess with your head. You're going to have a headache. You're going to be confused. You can even go into a coma. That's right, a coma. We're going to be hypoxic. We're not getting in enough oxygen because we're not putting out enough carbon dioxide. We're barely breathing in and barely breathing out. So I just want to tell you, the first signs of hypoxia is restlessness and agitation. Man, it's like you're kind of squirming around. Ooh, I'm feeling not so like I'm getting enough oxygen. Okay? Now, I just want you to think, whenever you have a patient that's restless, think hypoxia first. Don't just go try to dope them up with some Ativan. Check out maybe some oxygen first, okay? Now, I'm not saying there's anything wrong with the Ativan, man. Nothing wrong with the Ativan. Okay. Now, treatment. We got to fix the breathing problem, okay? We got to get these people breathing normally, okay? We got to treat that pneumonia, get rid of those secretions. We got to do some deep breathing exercises. Hey, if they got a collapsed lung, we got to do some chest tubes, okay? We got to do something to get these people breathing again. We need to encourage them to cough, turn, and deep breathe. Okay? Now, respiratory alkalosis. Here once again, respiratory. Who's sick? The lungs. Who's going to compensate? The kidneys. What are they going to compensate with? Bicarb and hydrogen. Okay? The problem chemical in respiratory alkalosis is the CO2. We are losing CO2, right? If we are in alkalosis, that means we are getting rid of our acid too much. We got too much. We're losing it. Okay? Our pH is going to be alkalosis. Now, what is our problem? Hyperventilation. Okay? Hyperventilation. Now, what are some reasons somebody might be hyperventilating? Maybe somebody's hysterical. I don't know. Maybe they're hysterical and they're just hyperventilating. Okay? That could be a reason. An acute aspirin overdose. Let me tell you about aspirin. Okay? Aspirin stimulates the respiratory system. It increases your rate of respiratory. So say you just popped, I don't know, 45 aspirins for some reason, got a headache. And now you're hyperventilating. Now you do that for a few minutes. I want you to hyperventilate yourself just for a minute. Just till your lips start feeling tingly, okay? Till you start feeling some numbness in your fingers and your toes. Do it. Try it. I dare you, man. See if you don't get tingly around your mouth, because that's what happens. You get lightheaded. You get faint. You get periorbital numbness. You get numbness and tingling in your fingers and your toes, okay? Because it's excitatory to your neurons. Now, what's the treatment? Are we going to wait hours and days for the kidneys to kick in? No, man, no, man. I'm going to hand you a paper bag. I'm going to say, hey, breathe into this paper bag, okay? That causes you to breathe that CO2 back in, okay? That's going to help you out right there. Now, we might actually have to sedate you, man. Sedate. We might have to sedate you to get your respiratory rate under control, but we got to treat the cause, and we definitely got to monitor those ABGs. Those ABGs is where it's at, baby. They tell you, tell me, tell everybody just what we need to know. Okay? Now, I'd like to go into some metabolic acidosis. We just got off respiratory. Now let's talk about metabolic. Now this isn't something that's going on in your lungs, okay? This is something that's going on in your body, okay? Got something else going on, man. Now who's sick? The kidneys are sick right here. That's right. Oh, goodness. Now who's going to compensate? The lungs. What are the lungs going to compensate? CO2. It's the only chemical they got. It's the only chemical they got. The lungs have CO2 to try to help the kidneys out. So what are the problem chemicals with the kidneys? The ones that the kidneys have, the bicarb and the hydrogen. That's the problem, okay? Now, is the pH going to be low or high? It's going to be low, man. We're talking about metabolic acidosis, okay? So what's the respiratory rate going to do with this? What do you think the respiratory rate? You got too much acid in your body. You got too much acid, so guess what? Those lungs go whoop, whoop, try to blow off some acid. They're going to try to get rid of some of that acid with the only acid they got, the CO2. Hyperventilate, baby. Get rid of some of that acid. Okay? The respiratory rate's going to increase and try to blow it off. Now, let's talk about some reasons why this would happen. How about diabetic ketoacidosis? Okay, now why does this happen? Well, let me tell you. Diabetics have a lot of glucose in their system, right? That's what got them kind of in the problem to begin with. Now, those cells in their body, they want that glucose. Ooh, they want that glucose. But there's no insulin to take the glucose to the cells. So they start breaking down fats and proteins so they can have some energy. And what does fat breakdown equal? Ketones, right? Ketones are acids, man. Those acids start building up in your body, start building up. You in acidosis at this point. Metabolic acidosis, might I say. Your lungs are trying to help you by blowing off some acid, okay? So what about renal failure? That could be another cause, okay? The kidneys actually get rid of some acids, don't they? But if you're in renal failure, you going to be getting rid of those acids? No, man, not the way you're supposed to. Severe diarrhea. That kind of hurts just thinking about. Severe diarrhea. In severe diarrhea, you're losing a lot of base, okay? Because the intestines have a lot of base. Now, if you're losing a lot of base, what happens to the acid? It's unbalanced. It's unbalanced, isn't it? You're pooping out the base, but you're holding on to the acid. We got a problem, okay? So, let's talk about what we can do to fix this. First of all, it depends on the cause, okay? Well, let's talk about the symptoms first. You're going to have hyperkalemia. What? Man, what does potassium have to do with my kidneys and metabolic acidosis? Well, I'll tell you. When you're in metabolic acidosis, your muscles start twitching. They become weak. You get flaccid paralysis and arrhythmias. Those are all signs of hyperkalemia, right? Well, what happens is you've got so much of the hydrogen ion, and it is getting into the cell, and every time it gets into the cell, it pushes the potassium out. They exchange. So now the potassium leaves the cell and goes into the vascular space, which is what we're measuring when we measure hyperkalemia, right? So too much of this right here actually pushes the potassium out of his spot into the vascular space. That causes hyperkalemia. Now, you're going to have an increased respiratory rate. That's a symptom, right? Why? Lungs are working hard trying to maintain your balance here. Lungs are working hard. Now, so to treat the problem, we got to figure out what's going on, and we got to do some stuff to try to help that acidosis. We'll probably get a one-time push of some sodium bicarb to help fix the problem. Hey, give me a call on my cell phone, and I'll tell you about some sodium bicarb, okay? Now, it doesn't fix the problem. It just helps the pH till you can maybe get the problem under control, okay? But let's talk about metabolic alkalosis. Who's sick? Metabolic, the kidneys. Who's going to compensate? The lungs. What chemical are the lungs going to use? CO2. Why? Because that's the only one the lungs have. Man, you listening? Okay, the problem chemicals are going to be bicarb and hydrogen. The client is in alkalosis, so are they retaining too much bicarb? Yes. And they're excreting hydrogen, okay? Alkalosis, too much bicarb, not enough acid, balance is out of whack. Balance is out of whack. The pH is going to be high. Alkalosis. Now, causes. Loss of upper GI contents. So you're losing your acid, man. You lost the acid. How? Maybe you vomited. Maybe you have an NG suction tube, but whatever you have, it's sucking out all the acid out of your little tummy. Out of your little tummy. Okay? Now, maybe you took too many acids. Antacids. I don't know. Maybe you like the way the tropical antacid flavored Tums. Maybe you like that. Maybe you're addicted to antacids and you took a bunch. But whatever the case, now you got too much base. Because that base offsets the acid and you just took too much base, man. Okay? Maybe me or somebody else gave you IV too much bicarb. I hope not, but could happen. Now, the signs and symptoms of metabolic alkalosis depend on the cause, okay? But I do know we got to observe the level of consciousness there, okay? Now get this. Put your thinking cap on. Stop your tripping. Do you remember how I told you that if you have metabolic acidosis, that you're hyperkalemic because so much hydrogen pushes that potassium right on up out of the cell and puts it in the vascular space. So really we could say that metabolic acidosis equals hyperkalemia, right? So guess what metabolic alkalosis does? Metabolic alkalosis actually does the opposite. It pushes potassium into the cell and out of the vascular space, leading to hypokalemia. Dang, this is messed up. So, okay, we got to monitor for cramps now and arrhythmias. So what are we going to do? We're definitely going to try to fix the problem. We're going to have to replace some potassium for sure. Okay? Now, last but not least, I want to talk to you about some norms, okay? Just look at this. The normal pH, 7.35 to 7.45, okay? The CO2, easy to remember, man. Easy to remember. If you haven't burnt too many of your brain cells by now, it's the same thing minus the 7, 35 to 45. And what about the bicarb? 22 to 26, okay? So, when we talk about these normals, let's try to figure out some people and interpret their ABGs. It's going to be short and sweet, I promise. It's going to be easy, baby. It's going to be easy. The first one, look at this. The pH, 7.32, okay? So, let's write down, what is the pH of 7.32? Okay? Acidic. Write acidic in that space. That's right, baby. Forgot my pen. Okay? So I'm writing acidic in there. Okay? Now, let's look at the PCO2. It's 41. Do you remember what our, same thing, except for without the 7, 35 to 45. The only thing about this one is we got to think. Okay? 41 is right in the middle. So that's normal, baby. Normal. I'm going to write norm here. Then the bicarb. It's 20. Remember, our normal bicarb is 22 to 26. So does this mean we have not enough bicarb? Yes. Not enough bicarb is going to be alkalosis, right? Or acidic. It's going to be acidic. That's right. So I'm writing acidic on here. Now, to figure out what is going on here, let's just match them up. We got acid and acid. Okay? So that gives us our answer. Is the bicarb a respiratory or metabolic? It's metabolic. So we are in metabolic acidosis. Okay? Metabolic acidosis for that one. Now, hold up, baby. Don't think you got this thing figured out. It's going to get just a tad bit harder. But I think with a little bit of practice, we can get this. Okay? We can get this. The next one, 7.56. Is that going to be acidic or alkalosis? 5.6. It's going to be alkalosis, right? I'm going to write ALK. Alkalosis. Now, the CO2, that's our respiratory part, right? Is going to be 31. Remember, it's 35 to 45. So 31 is too low. So, does that mean that we have too much CO2 or not enough CO2? That means we don't have enough. That means we're alkalosis, right? We don't have enough alkalosis. So I'm writing ALK down. And then the last thing that I want to look at is the bicarb. Remember, 22 to 26. So this is normal, right? I'm writing NORM. Now let's look back at it again, okay? And what do we have? Just match them. Alkalosis, alkalosis. So when we have alkalosis and alkalosis, what does that mean? What's messed up? The respiratory function. That is respiratory alkalosis, okay? Now here's where it gets a little bit tricky. Okay? Just hang with me. The pH is 7.26. What does that mean? Acidic. You are doing great. I knew you hadn't burnt too many of those brain cells. Okay? Now what about your CO2? This is your respiratory. 35 to 45. Okay? So this is 51. So that means you've got too much CO2, right? When you have too much acid, your acidosis, okay? Okay? Acid. In a good world, in a normal world, we would already have this thing figured out, right? We have on the past two problems, but hold up, wait a minute, okay? Put a little bicarb in it. HCO3, the bicarb, 22 to 26. It's 29. That means we got too much bicarb, right? Too much bicarb is alkalosis, right? So I'm going to write alkalosis here. Now we have not, up to this point, had one that had all three messed up, did we? Now, when you see these two right here, and they are both messed up, both of those numbers are jacked up. I just want you to know, one of them is compensating. Hey, I'm all about that. Go body, go compensate. But which one's doing the compensating and which one is messed up? Well, we got to match the pH. Whichever one matches with the pH is the one that's messed up, and the one left is compensating. So right here we have respiratory acidosis with a partial compensation. Now I use the word partial. Why did I say partially compensated? Well, I'll tell you. The whole point of compensation is to get this pH within normal limits. Now, if this number and this number are jacked up, but the pH is normal, hey, we are fully compensated, baby. Back in business. Back in business. Go compensation, okay? So, the pH is not fixed here, is it? So we are partially compensated. Something's working to compensate us. It hadn't worked yet, but we are in respiratory acidosis that is partially compensated. One more, hang with me, one more. I know you might have a decreased attention span. pH, 7.45. Woohoo! What is that? Baby, that's normal. That's normal. It's on the high end of normal, but that's normal. I'm giving that a big fat N-O-R-M for normal. Okay? Now, what is the CO2? The normal range, 35 to 45. A little bit high. Too much CO2. Too much acid. Acidosis. Okay? Now for the last thing, the bicarb. What about the bicarb? 35. Normal bicarb, 22 to 26. So we got too much bicarb. Too much bicarb is alkalosis. Okay? Now, we know right off the bat that seeing this and that they are both jacked up, we're compensating, right? But hip, hooray! We see that that pH is within normal limits, and that means that compensation is fully compensated, right? We are fully compensated. Go compensation, okay? This is what I'm talking about. Your body is bad. Bad to the bone, man, bad to the bone, okay? We still got to figure out what it is. Well, let's look. Anything over 7.4 Anything over 7.4 is going to be considered on the alkalosis side. Anything under 7.4 is going to be considered on the acidic side. So let's just look again at the pH and try to figure it out. You think that, yeah, it's normal. Go compensation, but is it closer to alkalosis or closer to acidosis? That's right. It's closer to the alkalosis, right? Now, which one of these matches alkalosis? That's right, the bicarb. So we have got fully compensated metabolic alkalosis. That's right, fully compensated metabolic alkalosis. Now I'm going to tell you, stay away from acid-base imbalances if you can, man. Okay? Acid will take you on a trip, a bad trip, a graveyard dead trip. Peace. Peace out.